So we have the last talk coming up before the lunch break. So I hope you can make it through. Yeah, I got Subrata here with me. And yeah, obviously I'm also one of the speakers. And today we'd like to talk a little bit about the thing around your system firmware, right? And that on the right-hand side should show a little bit that we want to redefine like the open source firmware, like everything is not equal there anymore and these kind of things. So what is the thing in your system firmware? As you are open source firmware developers, or many of you are open source firmware developers, and as part of your daily work, or if you work, you will see that open source firmware doesn't mean open source 100% firmware, right? So there are parts in your firmware which are closed source and which you cannot really trace, which you do not have any visibility into, and which you most likely can not really control on what it is actually doing, or you have limited control on that. So today we would like to go a little bit on that, like what is this all about and what we can possibly do about it. So yeah, as I said, I got Subrata here with me, like very long-term firmware engineer.
Yeah, so hi everyone. My name is Subrata Banik. I'm part of Google Chrome OS AP Firmware team. It's always great to be able to present in front of you all, and hope by end of the session we'd like to put some different thought into the open source model, what we are currently using. So all to you.
Yeah, and yeah, hi, my name is Chris. You saw me walking around all day here. I also have another job, which is I'm part of a company called 9Elements. We are an open source IBV, and I'm also one of the founders or co-founders of the Open Source Firmware Foundation. Okay, but it's not only us this time. We have a couple. We brought a couple of friends, and that would chime in later into the presentation. Sheng will do a case study with us, and we also brought Werner and Jonathan, who will like to share like what their thoughts are on platform enabling. Okay, to set the frame a little bit on how the presentation will go, you can basically divide the whole presentation into three parts, right? We have the problem statement, we have the solution space where we try to sketch a solution where we can iterate and go through, and we have that already talked about case study that we like to present as one of a small tiny bit actually that we already worked on. We will summarize everything in the end. So if you don't listen all the time, right, that's the part where to wake up again. So you get all the information summarized in very small details here. However, to set the tone really, why do we actually care? Like what is that problem really about that we talk about? We like to give you an introduction into firmware. Why do we care about firmware? What is important about it for us at least? How did it evolve over time? And what's the current state on that? Yeah.
Okay. So I think, look, so yeah, sorry for the mess. Yeah, I was telling that Chris summarized it very well. I think we're done with the session. We can just wind up. But okay, so these are very important questions that most of the people you have in your mind, that why system firmware is so important. Isn't it like a tiny piece of code that just runs on your hardware and done with the job? Yeah, it is, right? But then the other side of the question is that are we doing efficient design in the firmware? Or do you know that if we can design it wisely, it could be like a product distinguishing feature, right? Like maybe in terms of the BOM cost savings, maybe user experience and all. So we like to see maybe kind of like a four vertical to that, like how your firmware could impact to like improving your user experience, reducing the BOM cost, maybe optimizing the attack surface, and finally maybe improve your the product lifecycle. So as we all agree, in the modern days of computing, the user experience is a key platform or performance indicator. Every user wants to see their device up and running as soon as possible to press the power button or start the ignition. So no brainer there, right? Who really love to see that animation screen firmware is loading Still loading. Yeah, it's just hold tight. I'm coming up, right? So we want to make sure the firmware really have the value neutral, right? No positive, no negative, value neutral. That's the goal, right? So and when you think about that, maybe try to create a tiny firmware, how it impact to my BOM cost. We try to do maybe a high level job of splitting your laptop cost, right? The cost factor of your laptop, and the color in the pink that we try to show here. Hey, if you create a tiny firmware, it actually boils down to saving the BOM cost by $1 to $2. And one thing that we didn't highlight here, something maybe we can show it here, like whoever uses the proprietary firmware, they know that how much the hidden cost per device you have, right? So when you work on the open source, you don't basically pay for that cost, right? So eventually you are optimizing the BOM cost, giving back something to the buyer. Third is that reduce the attack surface. So our security researcher friend might agree with that, that modern days computing, maybe the attacker finds the firmware in a great place to introduce the attack because it's running at the very high privilege. And until and unless noticed, it remains very hidden, like nobody can able to catch it. And there are some study being done with the most of the firmware, specifically with the UFI. I love UFI a lot. But still, like 10 to 20 bucks per 1K line of code, right? If you could able to optimize more lines of code, maybe you are doing good job of maybe getting rid of some bug, some debug time, bug fixing, sending the update. And if you enterprise, like if you register to enterprise devices, right, you may know that every 4 weeks there are some updates keep on coming, right? Like maybe some cases 4 weeks, some cases of 2 weeks, right? So NIST enforces that you should have your devices never go out of the service. And typically for any OEM, the period is 6 to 8 years. The more bigger firmware footprint you create, the more chances of getting the periodic firmware update that it deals with, right? So with that thought, maybe we're moving to the next slide. So I think we agree now that firmware maybe is important, right? And it represents the business now. So it's no more like just a hardware initialization. Now it may be also represent business. So how do we do efficient design on the system firmware? I think Chris already talks about the three vertical to it. One is the visibility. As the name suggests, you let other to see the code and you expect the other also will able to show you their code, right? So minimum expectation that we have in the system firmware design is that the entire journey should be transparent enough, right? So what all the different components you need to create a system firmware, you should be able to see them at least, right? Or you should be able to know what they're doing it. If possible, those should be well documented. I don't think this is the great um, uh, expectation that nobody will able to meet it. This is the very minimum expectation that we are looking at forward, right? And once you compromise with that, so what basically you do, you basically create a maybe wall around you that, hey, this is my world. I'll not allow you to see my code and just get lost from here, right? So next is the traceability. So the way that you could trace something, right? So when you're talking about the traceability, right? What traceability means? Until and unless you actually do a good traceability job, you allow somebody to go out of their boundary. So that means like some firmwares become like a dump yard. Everybody's coming, say, hey, can we just increase maybe by 20 bytes? And then 20 bytes increase to 20 KB, then sometime 20 MB. So if you know, right, on the latest platform that we are working, we are actually going beyond 32 meg of spine, or we are just thinking maybe 64 may be the right way to go there. Because at first place, maybe the traceability was missing there. And then control, to able to influence, to able to direct. And that's also boils down to the freedom. Do I have the empowerment enough so I can design my own system firmware? Or I need to rely on SoC vendors to provide me firmware that they expect it will solve my problem as well, along with other trained people problem, right? So, or do I have a feedback mechanism? Suppose I fix an issue for my platform. Do I have a way to share that update with the others so they don't use the ideal time, right? So once you combine all these three vertical, right, I think this is all the fundamental purpose of the open source firmware. So we basically try to say that, again, saying that, hey, why not open source firmware in the first place, right? So we agreed that open source firmware may be the right direction through it. So and let's see in the evaluation of system firmware, maybe I just took liberty to draw maybe last 40 years of system firmware. Maybe I have Ron here. Ron knows much better than this one, right? So yes, so only one thing that has remained consistent in this entire evolution process is that this red line, right? From its origin till date, I think if one thing is still remain consistent is that the closed source nature. It started with the close, it's still preferred to remain closed, right? And if you see there are other streams that actually like originated when the closed source firmware was there. There are U-boot, there are code boot who are always trying to come to the mainstream and all, right? But yeah, last 10 years, it was maybe like in my opinion was great, where it is not only few people wish about the open source, maybe the different organization, different companies are coming up with their demand, hey, I need the firmware to be open source. So the organization that where I belongs to, Chrome OS, it just very clear directions about the open source firmware. So maybe the ball started rolling a little bit, right? So what we heard in last 1 decade, we heard about a new term called hybrid firmware. So just don't go with things like that. This is a hybrid work model, 3-day going to office, 2-day work from home. Not like that. So this is that marry between closed and open source, right? So you try to do a good job of balancing it out, which as a community we all accept it, right? But like what we see in the downside, right? We have seen there is a underneath of the mammoth growth of the closed source firmware, and there is no visibility, no traceability, and no control, right? So things are getting more and more controlled by the silicon vendor, and code boot cannot escape that as a fact, because that is also kind of a open source boot firmware. You need to rely on silicon provided libraries and all, right? So we again going back to the same thing where we started, that there are something, the things around your system firmware that controls your movement, that controls your free movement, and make you to do what they want you to do, right? So it is not a real open source. So with that note, we thought of maybe make some statistics, right? Just to state the picture that what we use today is a real open source or not. But before going there, just thought of setting a role model. I think our role model would be complete open source development, which is a two big things to ask. But if you go into C and core boot community, we have already some example of some chipset which is actually doing even the MRC initialization, which considered as the utmost secret, the open source, right? So this is always a, like in your life, you always should have some wish list. So for me, this is a wish list. Hope all our chipset vendor would agree to that point, and we agree to the open source firmware at one day. But let's come to the reality, right? So this is a real picture of the current open source firmware with almost all the leading associate vendor we have. Purpose of this session is not to deep dive into each and every component, but just to leave you guys with a thought saying that, hey, how much of this you could see as a green, as a real open source? You can see there are more dark or like a gray color, black color things, right? Those are considered as a closed source firmware. Right. I hope that is okay to set the context. So are we really doing the open source firmware development? Let's quickly go to the study. Right? Like this is a pie chart that we prepare based on the data available with us. And this is definitely not what we shown in the first slide, where we shown the Tai Chi picture about the define the balance and harmony, right? So clearly looks like the balance is broken somewhere. In your SPI, you are basically packing something which is more than 50% closed source, and we are claiming we're working in the open source firmware. Okay. So our talk here is that we understand the problem, and we know there is a call for action, and what we can do as a part of community to define a step-by-step approach. So let's go into it together. So I'll hand over to Chris. I'll take it from here. Oh, sorry, this is my talk again. Sorry, I just missed it. Okay, so looks like we just set the context so far about the paperwork of the problem statement, right? So let's try to see what's more we have apart from the problem statement that we talk here, that visibility, traceability, or like unable to control it, right? So whoever work on the codeboot project with a different SoC vendor, you will familiar with this kind of interface. When you work with the x86, it's Intel, you know there is a term something called FSP. When you work on the ARM, there is Agisha, and then with the QC, the Qualcomm, maybe there is a QC lib, right? So those are the interface. That interface allow you to talk to the silicon reference code, right? But in the top layer, you have code boot, which is kind of a unified. It has its own standard. It has its own specification. It defines clearly what the job of boot block, ROM stage, RAM stage, etc. But what is cost for code boot, right? Code boot cannot create a unified library across different SoC vendor. You need to maintain its own different driver libraries. We have a bunch of maintainer working on the different project. When we move from one project to another project, for an example, I typically work on the Intel platform. The moment I move to the AMD platform, I need to think, okay, I need 2 months of time to learn myself how this new interface works, and then only I can move, right? But it is not benefiting everybody. So we need to think about an interface that solves everybody's purpose, like a unified interface which defines the specification, and even it will help to create a one more vertical. What if tomorrow there is a new SoC vendor say that, hey, I want to use codeboot? Are we doing good job of saying that, hey, yes, this is my standard, this is my specification, just follow that and land your code, rather than we are letting them to decide it, and later we are claiming, hey, SoC vendors never listen to us. They create their own standard, because at first place we don't have any standard. And then maybe if you just think that codeboot is going with all the different operating system and all, right? So you're like the user of the different operating system, or the user those buying those devices, or the platform engineering guys, right? They expected to receive a unified experience. When I work on some of the ARM devices, I could see the SPI size is so tiny, like sometimes 4 meg, sometimes 8 meg. But when I move to the x86, I could see, oh my God, 16 meg is minimum, and then go to 32 meg, then 64 meg, 128 meg, what not, right? So how do we define a unified spec, saying that, hey, work on open source, work on codeboot firmware, this is your spec, right? Just try to provide me a unified experience. And most importantly, we are all developer, but people often forget about the value of validation, right? How do we say that there is a test framework been developed around my codeboot that basically tells my silicon programming is really trustworthy? We are just living in the boundary. We just trust on every developer done their good job, they meet their requirement, and we are shipping the devices, right? So yeah, I just given the handover one slide before to Chris just to upload my work. So now it's the real Chris.
All right, thank you. Yeah, another thing that we have to understand is that the model kind of changes how we want to develop open source or open system firmware. So that means, from a traditional point of view, there was like a 1 to N relationship. So that means that the SoCs have to work with the IBVs, and that's like a handful of which is really there. Everything is already settled and in place. They have all the NDAs in place and so on and so forth. They know how to work with each other, and the SoCs kind of enable the IBVs that then they can scale basically all the OEMs and ODMs. However, we are moving from that traditional model into a modern model, right? Like a modern ecosystem. And we have different challenges there as well. And one of the challenges that instead of having like a 1 to N relationship, we have a 1 to N relationship, right? So it's something that we call enablement partners, is that the SoC vendors have to enable their enablement partners and scale them already so that they can then scale up the whole thing. And this is something that's a challenge that we have to work on. And that link right there between the SoC vendors and the enablement partners is currently broken. It's a challenge for SoCs or for SoC vendors to really enable all the enablement partners, right? So it's hard to enable an ISV. It's hard to enable the community. There are a lot of barriers around it, around NDAs and how to get access to, I don't know, hardware and resources and these kind of things. And that is really lacking right now, and that is one of the biggest challenge that we have right now. And with that, I'd like to get our friends and industry partners basically on stage to share their vision. And I think Subrata will
Yeah.
take over Cyrus Pass first.
Yeah, so initially we thought like maybe we'll just leave with our thoughts and we'll ask out the different industry, like people from the industry who use this code boot, and they just come and then share their thoughts. Unfortunately, Cyrus from the Google Chrome OS team couldn't able to join with us today for some other reason. I thought to maybe fill him in. So I think you all know that Chrome OS is critically committed to the open source, but what is really open source mean to us, right? So we, like at one day we want to see that all the different firmware that we packed inside our Chrome OS devices should be open source, right? So if not today, at least our focus is that mostly right now on the AP firmware, EC firmware, and the GSE firmware, right? So objective is very simple: to empower your partner and just don't reinvent the same wheel again and again, right? So and like when you enable your partner, I think that is what Chris just said. It's now like a 1 to N model, right? And I'm so happy that I could see all the community people, right? If I just take one people name, other gets angry on that. But it's a great thanks to the community for helping us, and that really helps to minimize the product development cost. And I think that should be the one great motivation for everybody to say yes to the open source firmware development, right? So what problem we see if we just don't do the open source? So the first problem is we see that there are much engagement required from the Googlers to sit behind every OEM, ODM. We just basically say no to the scaling because like we are like a handful number of people. We cannot sit behind every device and try to enable them, right? So it is very difficult to scale when you do not get everything in the open source. Second is the duplication of work. So although SOC vendor claim they're doing things differently, but in the nutshell, they are all similar, but they are all incompatible, right? So yeah. And finally is that we want to push back to the some requirement, like a boot time requirement. Oh, we cannot meet a 1 second boot time requirement. Few people are meeting, right? Few people are doing good job with the SPY boot requirement. So we want to create that harmony, right? That everybody is sharing and carrying their goodness to it, right? So with that, I would like to invite Warner to come and talk about his business group.
Yes, hi. Thanks for having me here, Subrata. That's better. Okay. So for those of you who are not aware of what I'm dealing with, we are creating CNC machines for industry standards for milling turning devices, and which brings in a hard real-time requirement. And in terms of firmware, we really need the overall control of the layer in order to make our real-time case working the right way. And we indeed need fast boot times because the machine operator don't want to wait too long for the machine to come up to start productive. And the other thing that we have is that maintainability is a case for us because in industry standard, usually you have delivery times of up to 30 years and lifetimes of 10 years after the project has disappeared from the order list. So we need to stay maintainable of our devices. We need to take care of security things, and that all of these things draws the need for us to be in the control of the firmware layer. And moving to Coreboot from 2015 for that devices, we still see that these closed source portion of firmware that Subrata mentioned starts to be an issue because security issues arises from there, and you need to fix things up because you are not in control of that. You need to wait for fixes from the SOC vendor to that extent, and all of it makes it hard for us. And this is why we are requesting a more open source portion of all of it, because we need to control that in order to provide good devices to our customers and to our machines.
Thank you, Anna. Thank you for your time. Yeah, I'd like to invite Jonathan. Hi, Jonathan.
Hi. So we actually call it the move fast and the break things. So anyway, so joke aside, so joke aside, I only have 2 minutes, so I want to be able to say everything I want to say. So, but I'm around for today and tomorrow. So for Meta, our scope for the open source firmware is, yeah, this is not just Meta. This is just about the hyperscaler. So Balance is planning to put OSF into the server fleet this year. Meta is working toward production ready status for OSF. So So basically, we are at schedule, feature, stability, power, performance, everything on par with traditional firmware. We use OSF as a tool for server program. So we use it to develop a new technology. For example, compute express link. For example, we provide references. We say, hey, this is the number we achieved, like boot time, memory availability, not traditional software firmware. You need to achieve it as well. So as we use it as a hammer, as a tool. So how does the open source firmware help us? Kudos to the people sitting here, right? You all helped to form it up. So we use it to untap the Linux talents. We accelerate the time to production. We want to accelerate it from the time the silicon vendor production launches their SoC till we get it into our data center. We want to shorten that. We accelerate the debugging and provide references. So now it comes to pain point. Thanks everybody. I hope everybody trusts my intention. So, but allow me to vent a little bit here. I'm okay with like eggs thrown at me. So first is, the hyperscalers, right? So most people in the hyperscalers, they actually don't care about the firmware. You just say, if it works, it's good enough. So now, what can we do to convince them, right? They are all smart guys. Why do they get into this? So it's because we need to achieve our claims, right? We say open source firmware is better, but are you really better? Right? So we say it has a great ecosystem. Do we really have a great ecosystem? How many people are working on it, right? So if you want to work on Coreboot and and Coreboot, of course, needs to cover all the segments, and you don't have access to servers, $10,000 machines, just let us know. Hardware is not a problem as long as you really have the good intention. We do have OSF for a few generations of Intel CPUs out there. It just runs. So if we look at the right-hand side, look at the diagram that in 2019, we started a proof of concept between Meta and Intel. And then by 2021, we have FSP, a statement of work. And we have the OCP Delta Lake server. We have everything on the GitHub. So you can download the build and have fun with it. And then this year, we actually have an industry coalition with like all those names over there. And some names I couldn't put there because of sensitivity. But we are working on that. So that's my third hat, is besides Meta engineer and OCP OSF lead. And I also work with a lot of people here toward a industry coalition. So we are not alone, but not big enough. So I hope other people, other companies could join. So what issues I see with our community, right? We are all smart people, but I do see sometimes we need harmony and we need to gain friends. So we should not do semantics over solution. Technical details is important, but sometimes we need harmony and we need to like just get something done. Sometimes people do talk over action. So let's just roll our sleeves and get things done. Lack of differentiation, kernel OS community involvement should help, right? So in the last week's Linux Plumber conference, Ron and I had a BOF, but we have seldom any people join. So we need to talk to the kernel people, talk to the bootloader people, right? For example, one idea I have is firmware is not about just boot anymore, right? The flash, the next generation servers could have as big as 128 meg of flash. A lot of things can be done there, like manufacturing, like maintenance, debugging. A lot of work can be done just from firmware. You don't need to run OS because OS is in the firmware, and there's no support for Windows. So that's actually important for us. From Meta viewpoint, we don't care, but from the industry, we have to solve this problem. Thank you.
Thanks. Okay, I guess we kind of all agree of that there are a couple of problems around that. I think you're gonna switch it. Oh, yeah. That there are a couple of problems around system firmware, and that we have a couple of things to address. And now we have to think about how can we address them, right? What would be a way forward to actually solve all these problems, to solve community engagement, to solve that we don't know how things work, to solve on that we have different interfaces, and Subrata always has to spend 2 months to get into a new architecture. So for us, we see a way forward starting with documentation, right? Documentation kind of, so the whole picture should show you like that documentation can fuel the community, that can in the end fuel standardization, because this is what we most likely also need in the end. So if we look into documentation, documentation is a key part to get more people involved. Right? Many things in firmware is just not documented. And I don't mean only public documentation, but also NDA documentation, for example. Sometimes within SoC vendors, it's hard to get, even if you got proper NDAs in place, to really get documentation on how all the internal works. So providing documentation, and ideally that should be like real documents, but sometimes code can also be kind of documentation there. To provide documentation on how things work and also how processes work, like what if, or how should the process look like when the community wants to contribute something back? Like how does that whole thing work, right? We need to write that down. We need to document all these cases. And actually, not everything is bad, right? So there's already a lot of documentation going on there. And also SoC vendors start to do that and to kind of open up in this term of getting more people involved. As a showcase, I have AMD here that provides like much more extensive documentation to a closed source group, right? To a group under NDA, but still pushing the limits there and already getting more people involved into that. So that's like the first thing that we need, right? Documentation. Once we have everything documented, you can actually enable the community to do the work for you, right? I think the current idea or what is also wrong there is that SoC vendors think they have to do everything on their own. They have to do all the lifting, the heavy lifting on their own, which is actually not true. Just document the parts and how it works. Community will most likely do the rest if they need it, right? So documentation can fuel in community engagement and how how things are developed. Also, engage the community early on. That means don't, like the current process right now is you just drop something at some point in time, and then, for example, Coreboot community has to work around it, how to actually get it included into our firmware solutions. Engage them early on, right? Work with them together, basically on enabling your products and your SoCs there. Provide more access to broader groups, right? Support the community, and with the community, that's like the whole ecosystem. Support them throughout the development. Like how you as a firmware developer, if you're doing that basically for fun, how do you engage Intel or AMD or ARM or so, right? How if you got a problem, like how do you get it solved? This is something that we need to address. There are already also a couple of showcases around that. Jonathan's leading an MP-NDA group on Intel scalable systems, where we have a broader group that really gets like first level support from Intel. AMD is also engaging the Coreboot community very early on now for future platforms. So things are looking better, right? But I think there's still room for improvement there. And also, we need hardware access for some things, right? Not everything is that you can buy something like $20 off the shelf. I mean, Jonathan just said hardware is not an issue, right? But that needs to be documented. How does it work, right? How do I get access to hardware? Like, how can I move forward on these kind of things? And obviously, we need standards. I mean, you can like it or not, but somehow we have to agree on the same language at some point in time. So we have to define standards on how do we work around silicon initialization blocks, right? Like what interfaces are there? How do we communicate? How do we hand off data from firmware to bootloaders, right? How does that happen? How does the bootloader hands off data to an operating system? And all these kind of things. That all needs more standardization, especially for for open source firmware, because we got a lot of use cases that do not fit the specification that is already there. One crucial thing that I learned is that standard should be on neutral ground. So that means not an SoC vendor should control the specification, because then most likely it's easier to change it. So there should be more people involved than just one company, basically, to own that specification and to publish that specification. And there are a couple of things already out there that you can use. There's the Open Source Firmware Foundation, Linux Foundation, there's OCP, where we can actually put these standards into, so that not a single company or single person has control over it, rather than more people. And it's a collaborative effort between SoCs, vendors, IVVs, community, and the whole ecosystem there. Just like a little bit of advertisement on the Open Source Firmware Foundation there. We are, so as I'm one of the founders of the foundation, we can act as a mediator there. So if you have any problems, let us know. We will try to get the ecosystem together and find someone for you. We don't have to be, but we can be neutral ground for specifications. We trying to give you directions, like how does a more open ecosystem works and how does it look like. We don't have like all the solutions there, but we can just speak from basically our expertise that we have there. And we already have a couple of work streams that are dealing with these kind of problems. For example, the silicon initialization blobs that Subrata just talked about, also firmware security and these kind of things. Come to us, talk to us, and be part of these work streams. And now, as like one tiny output or small output of one of these work streams, Sheng will go through one. Subrata will go together with Sheng through one of the case studies that we have.
Perfect. Thanks, Krish. Thanks for sharing that. So yeah, may I get Sheng? Yeah, you can come to the stage. So this almost like a last topic for our today's session. Yeah, sorry, it was like a pretty stretchy. So one of the case study that we like to demonstrate here is basically like some work that I've done in last couple of months to exhibit that how the work model between Core Boot and the Intel platform FSP could have been done a little better, right? In that case, that provide more freedom, try to basically reach at the stage where we decide our own fate, we decide what we want to create in our own product, right? So we just don't have to use the same binary model that is released by the SoC vendor, and we could have a flexibility to reduce the fruit bin by dropping the unnecessary features, which is somewhere being documented somewhere, and eventually to help to improve my BOM cost, my user experience, and all the other things that we mentioned in slide 4, actually, right? So if you see the entire SPI size that I just depict here on the some of the last generation Intel platform, so around 20% of the SPI size just belongs for the FSP. So when you talk about 20%, there is a reason to be really worried, and there should be some effort to spend there to try to optimize it, right? And on the other hand, if you see the growth between last 5 generation, you could see there are 2x amount of growth, and that is what we talk about the traceability. If you are not measuring now, maybe after 5 years, there is no point of talking it. Also, there is no point of talking at this stage also, right? Unless we come up with a industry standard or specification, right? So this is the background of this case study, and I call it like a alternative path, because the straightforward part is that all the SoC vendors say one day yes to the open source. That's a straightforward path, and we call it the alternative path because here we want to gain more control. So how do we want to gain control, right? So just try to take a look into this, right? So this might be Intel SoC, but it's not different with any SoC, where there are a bunch of IPs. The IPs are capabilities that getting exposed by your platform drivers, your OS, the user experience and all. And then other hand, you have a silicon reference code. In this case, might be FSP, which basically try to complement your IP initialization code. So from the SoC vendor side, they're doing great job. They are releasing the package for everybody to use it, right? They're like one monolithic block that solves everybody's purpose. But when we started looking this from the OEM side, right? So do I need a binary that solves everybody's purpose? No, my use case might be different than yours, right? So what we come up with the proposal. And also same time, it's also important which boot firmware you're using. If you're using Core Boot, which is quite competent enough, why should I rely on FSP to do most of the stuff, right? Chris already mentioned that. Just don't assume that you're the only one who will do all the stuff. right? Rely on your boot firmware, right? So we come up with that model and where we just say, hey, in your FSP, let's do it something called a must have or good to have, right? So once you say must have, we will not challenge you. What's a must have? You basically know your silicon better than us, right? And we want to see if there is a good to have modules which you already implement using core boot. Can you just grow and chop those pieces, right? And create something which is like a reduced footprint FSP, which solves my purpose because there is like a tiny restricted secret code which you only cares and your platform should be only caring, and open source community really don't care about it, right? So in this process, we not only able to create our own firmware, we control things, right? We can create a thinner footprint, all those issues that we talked about, right? The bug fixes and all been taken care in this case. So this is the architecture behind this alternative path. And Shin will talk about the real implementation of this part. Over to you, Shin.
Thanks, Subrata. So I'm not sure if anyone aware that a few months ago, there was a love letter to Intel, open letter to Intel on the adapting open source for the FSP. So in that open letter, there was a nice, well-written article drafted by Subrata. So it stated that there's a 3 basic approach that how can we minimize and make FSC more adoptable and open source for everyone. So in these 3 solution, they are very streamlined and they are very sensible. So I will show you what are the 3 solutions. So the first one, as anyone of you who work on FSP before, so you know that FSP has different API where you have to call in, call out, call in, call out a few times to use the FSP. And then one of these FSP notify APIs are in the FSPS, which is the silicon phase, which is the third part of the FSP. And in this FSP notify phase, what they basically do a lot, if you can see the code, is basically they do a lot of security register settings to make sure that the security are in line with Intel's security requirements. So all these things can either be done in FSP or in core boot or any open source solution. There's no problem. So that's why the first step was also implemented by Subrata, which is to move away from the FSP notify phase, and we let the security register setting be done natively in the core boot. So this is why the first step. So, but if you look back at the Intel approach, in order to do these 3, they have 3 notify phase, which is end on firmware, ready to boot, and
End of format 2.
Yeah, end of
1,
format
2,
2.
and ready to boot. Yeah.
So you can see with this minimized approach, we save a lot, a few boot times and more streamlined flow in this first approach.
Yeah, and more importantly, right? So that piece of code that we are talking about. So if you are anybody coming from the OEM or IVV background, you know that these are the old document that Intel sent previously, like maybe 10 generation before, that say these are the 20 registered. Just before shipping, just make sure this register having the right value. If yes, then the ship it. You are good. So we are talking about those 2000 register programming, right? Nothing beyond that. Go ahead.
Thanks. Okay, so the second part is that in last time, in few years ago, so FSP was being done. Sorry, the multi-processor init was being done in the core boot side, but you can look in the history in the document. So it has been moved to FSP since then, but now we have a chance to move back to core boot with this approach. It shouldn't be complicated to actually do the multiple processor initialization, and it should be a more native approach to come from the bootloader itself to program it.
Yeah, so just to add to that, right, I think you can only blame me for doing that in the first place, but that was the need of that hour that's been done there, right? And this is the principle that we want to drive, that, hey, just take some decision and after some time, just come and reevaluate the decision. What's been done in 2016 may not be the rightly valid in 2022, right? So yeah, well, that time devices need some voodoo programming to be done in FSP, but now it's not needed anymore. So just bring back the free freedom to the core boot. Let core boot do all these things. Go ahead, Shin.
Okay, and the final approach is that use the open source projects over proprietary firmware module. So for example, the one thing that has been done in FSP is doing the graphical init. So everyone has a pain point for using the Intel GOP. Yeah, I feel you. I have a few. So one of the best, because you do know what why your display didn't get initialized. There's no debug output at all, and then you don't have access to source code and don't know how to program it. So when they move to the libgfs, which is what we are doing now, and then you can exactly pinpoint, okay, why your DP doesn't work, why your HTML doesn't work, and then you can try a few, you can program yourself. So basically the key principle is here to enable us, the developers and OEM, to have more control of our own firmware instead of we rely on certain vendors to roll out, to spend months to roll out the fixes over that time. But we, at ourselves, we have the control to do it ourselves. So that's the main principle. So with this POC, we can see that initially in the FSPS as 716 KB, and we can reduce, after we remove all this redundancy, we can reduce to 180. So you can do the math. It's actually 75% reduction by itself in the FSP block that are not needed. And then we just move to the corporate side. And from there, you can see it for the overall BOM list, is we save 5% with just this minimal approach. We save 5% of the BOM space for this. And there's more can be done if you further optimize it. This is just getting started. So anything to be added, Subrata?
Perfectly fine. So I just like to take this liberty to say thanks to, okay. So thanks to Intel team to acknowledge this effort, and I got approval from them that they are documenting all these changes, what it called like a must-have and good-to-have modules, and they are going to release some tooling around it. So going forward platforms, we might have a better flexibility to drop those modules with against Corbo. That is a really good job, and that's aligned with the ball started rolling, and we might see a better open source firmware in coming days. With that, we are almost done. Chris, what do you?
Yes, we kind of heavily extended our time, so I think we kind of need to switch the Q&A session. All right, but yeah, that's the time basically to wake up again if you fall asleep to get the summary. As I think it should be clear now that firmware is, or the value proposition of firmware is far beyond just doing hardware initialization, right? I think Subrata made that very clear in the beginning. The new modern model that we're working in, it's looking for more freedom and more collaborative approaches throughout the SoC vendors, right? So the enablement partners need to work together to meet these goals, and also the SoCs needs to shim in there. We need more specification around this, because like a lot of SoCs are doing their own thing in these kind of in that area. So we need to drive that forward to ease the whole platform enablement process. OSF development becomes, yeah, or let's say it should be friendly documented, right? And there should be more documentation around it. So then to ease like the whole OSF development process. And yeah, you can take a look at the alternative part, which is not the only path, right? But it's like one path that is there in that specific area that Subrata just sketched. And we already moved like a lot of forward, right? And already.
Is it tiny? But I said this is like maybe one step at a time.
Yeah, but for me, like looking at the numbers is already huge, right? So yeah, if you got any questions, feel free to contact these people for technical contacts on the Open Source Firmware Foundation, on the Silicon enablement or platform enablement in general. And also come to me or Subrata if you got any more questions about the talk. I think
we are done.
We are done with that, yeah.
Thank you, Chris. Thanks everyone for having been such a great audience.